By 2030, we face a critical energy choice. Keep the lights on in our homes, or keep the servers running for artificial intelligence. You can't have both. AI is consuming electricity at a scale we've never seen before. Meanwhile, traditional nuclear reactors take 15 years to build, so the math just doesn't work. Silicon Valley believes it has the answer: small modular reactors, or SMRs. Think of nuclear reactors the size of shipping containers, built in factories like cars, and deployed in months instead of decades. This is the story of 4 companies racing to build them. But not all of these reactors are created equal, and this race will determine who powers the future. Let's meet the players. First is NuScale Power, the regulatory winner. They're the only company that has already won approval from the U.S. Nuclear Regulatory Commission, which is a massive advantage. They've partnered with the Tennessee Valley Authority and a company called Entra1 Energy for a historic deal. They plan to deploy 6 gigawatts of clean power across the American South. Their reactor uses proven light water technology, the same design that's been used safely for decades. The main advantage here is regulatory certainty, with no surprises. The challenge is their modules are smaller, so they need more of them to generate the same amount of power. Still, they are the closest to the finish line. Then there's TerraPower. Bill Gates bet on the future. They are building an innovative reactor called Natrium in Wyoming, and construction has already started. This reactor is different. It uses liquid sodium as a coolant, which transfers heat far more efficiently than water. And here's the genius part. It has built-in energy storage. Imagine a battery the size of a power plant that can ramp up instantly when the grid needs extra power. This flexibility is revolutionary. The reactor is also bigger than NuScale's, meaning fewer units are needed, a major economic advantage at scale. The challenge is its complexity, but if it works, it could be the gold standard for next-generation nuclear power. Kairos Power represents the steady hand in this race. Backed by a substantial contract with the U.S. Department of Energy, they're building a demonstration reactor in Tennessee. They are using a molten salt coolant, which is actually a proven technology from the 1960s that they are reviving with modern engineering. Kairos is building everything in-house, from the reactor components to the fuel itself. This vertical integration allows them to control quality and drive down costs over the long term. Their advantage is stability and proven concepts. The challenge is timing, as they are targeting 2035 for commercial deployment. They're not just racing to be first, but to build a sustainable and scalable industry. And finally, we have Valar Atomics, the Silicon Valley moonshot. This company is backed by technologists from the defense and intelligence sectors. They're building a high-temperature gas reactor that can do something no other SMR can: produce hydrogen. Imagine a reactor that doesn't just generate electricity, but also creates clean fuel for trucks, planes, and ships. They recently hit a major milestone when their test reactor went critical. Valar is the most innovative and ambitious of the group, but they are also the earliest stage and have the furthest to go. If they pull it off, they could redefine what nuclear energy means for the world. Here's the geopolitical reality that keeps strategists up at night. While the West races to deploy SMRs, China is quietly building nuclear capacity at an unprecedented scale. They are constructing roughly half of all new nuclear reactors in the world right now. More importantly, China has abundant cheap electricity, and they're using it to build massive data centers for AI. They understand something the West is just beginning to realize: energy is power, literally. The West is betting on SMRs as a faster path, but China's state-directed capital and existing supply chains give them a major advantage. This isn't just a corporate competition. It's a geopolitical battle for dominance in AI, robotics, and the global economy. The future of human intelligence depends on solving this energy problem.